All right, we'll come straight into the Pythagorean identity. I'm not too sure who we've got, but the complementary angles is something I think in the past that we've left for year 11 and we've picked up in year 12. So I'll skip those videos, and if I need to go over it when I get back, we can. The Pythagorean identity today is just really our Pythagoras' theorem. If that's oh, if that's a there and that's b there, I know that a squared plus b squared is equal to c squared, which is 1, which makes sine squared plus cos squared equal to 1. Okay, so it's a way we can work out our sine and cosine values from our from each other, if you like. And I'm going to show you two ways to do this. So if I want to use the Pythag identity, so if sine x is equal to 3 on 5, that means sine squared x is equal to 9 on 25, yeah? And I know that cos squared x plus sine squared x is equal to 1. So cos squared x equals 1 minus sine squared, which is 9 on 25. 25 on 25 minus 9 on 25 is 16 on 25. So cos x equals plus or minus the square root of that, which equals plus or minus 4/5. Now, to determine whether it's plus or minus, we look at the domain that we're in. So pi on 2 to pi is there, that quadrant there, and cosine's negative there. So cos x has to be negative 4 on 5. Yeah. If I want to find tan x, well, tan x is equal to sine x over cos x, which is equal to 3/5 over negative 4/5. Flip it upside down and multiply. 3/5 times 5 on 4, which equals 3/4. Quadrant, second quadrant, tan is negative, so tan x is equal to negative 3 on 4. So that's really using our Pythagoras' theorem, okay? The alternative way we can think about this is every time we get sine, cos, or tan, just mark a triangle. And in this case, we've got sine x, so the opposite side 3 over the hypotenuse, because I've got sine x equals opposite over hypotenuse. If I use Pythagoras' theorem now, 5 squared is equal to 4 squared plus 3 squared. So I've got the 4 value, which means now I can work out what cos theta is. Well, it should be an x, shouldn't it? Cos x is adjacent over hypotenuse. Tan x is equal to opposite over adjacent. The only thing you need to now go back and do is the same thing about which quadrant am I in. I'm in the second quadrant, so that has to be negative and that has to be negative. So whether you use a Pythagoras' theorem approach or draw a right angled triangle, we'll get to the same point. I'll leave you to it.